Yeah, you got to remember that this is going to go all the way back to very beginning of chapter 3. So like for this one here, this is basic quotient rule here, right? So in this case, I've got, remembering what the quotient rule is, that's f prime g minus g prime f all over g squared. And again, I am okay if you do not square the bottom. If you just leave the bottom as it is, that is completely fine with me. Here's what I mean by that. Okay, so let's find f prime. Well, what is the derivative of the top? 3. Times the original bottom, 4x minus 1, minus the derivative of the bottom, 4, times the original top, all divided by 4x minus 1 squared. And then all we have to do is just distribute. So this is a 12x minus 3 minus 12x minus 8. Oh, cool, that's convenient. So the 12x's cancel. And then I get a negative 3 and a negative 8, which means, sorry, this is still over that. That's a negative 11 over 4x minus 1 squared. How do we do? We do all right?
Yes.
Yes, sir.
Yeah, I think that was the.
No, I think it's after that because he said, "I'm not afraid anymore." Already.
All right. I don't know. All right, let's keep going. We've got cotangent x plus cosine x. Now, do we have to do any sort of weird rule on this one? No, because this is just a sum. I'm just adding these two things together. So I just got to take the derivative of the cotangent plus the derivative of the cosine. Well, the derivative of cotangent is negative cosecant squared. So y prime is equal to negative cosecant squared of x plus the derivative of cosine, which is negative sine. So minus sine of x. Can we do anything more with that?
No.
I don't think so. I mean, I may try to look at some identities, but
You can take out a -1.
you could take out a -1, make it cosecant squared x plus sine of x. But I don't think that does anything.
That'd be useful.
Cosecant squared is 1 plus cotangent, but again, that doesn't do anything either. All right, so we could leave it like that. That's good with me. Looks like that one is just there to test you on some of your trig identities. Remember that you do not get this paper, right? You do not get the original derivative sheet, but you do get the 311. This. I will have this provided for you. All the hyperbolic stuff. All right. Let's keep it rolling. Number 3, find the derivative. Now, I've got to do some derivatives here with some trig and a quotient rule. So let's take a look. Okay, y prime is going to be f prime g. Okay, derivative of cosine, negative sine again, times the original bottom minus the derivative of the bottom. Now remember, the derivative of cosine x plus 3 is just, see what happens with the plus 3? That goes away. That doesn't stay a 3. Okay, that will go away. So it's really just negative sine again. Times the original numerator. F prime g minus g prime f. All over g squared. Cosine x plus 3 squared. Okay, let's see what we can do. Looks like we can pull out a cosine, right? Or sine, excuse me. Yeah, we could pull out a negative sine, can't we? So that would be a negative sine x. Now watch this. Be careful here. This is a negative sine x all the way on the outside, and then that's going to be cosine x plus 3 minus cosine x. Okay, be careful with that. all divided by cosine x plus 3 squared. Because the reason why it's a minus, and that's going to cancel, is because that minus in there. The negative got carried all the way out. So that doesn't cancel, make it a positive because we remove it all the way. So we have a negative sine x plus 3 over cosine x plus 3 squared. And I believe that's all we can do with that. Uh-oh, you're looking at me like I'm weird.
Why would it be plus 3 if it's in parentheses? Wouldn't you multiply back in?
Oh, yeah, that's multiplied by. Ooh, not a. Yeah.
Negative 3 sine of x.
But honestly, it's just times 3.
So negative 3 sine of x.
Yeah, negative 3 sine x. Yeah, I guess we should write it like that. That's a little bit more formal. Negative 3 sine x over cosine x plus 3, quantity squared. Is that him watching that movie?
Yeah. No, I was getting a pizza. Where he gets a pizza box?
Yeah,
You feel the animal.
Where they're at? Is that where they're at?
No, Marv's trying to break in and he just played it and he's talking about how someone named Snake just got headphones.
All right, questions about that one? Okay, let's keep it rolling. Okay, product rule, right? Product rule. Now, honestly, there's two ways to solve this problem. You could multiply, then take the derivative, or take the derivative and then simplify. Like, for example, here. Again, product rule just states that f prime g plus g prime f. Right? F prime g plus g prime f. All right, so let's find the derivative first using the product rule, and then maybe next I'll multiply and then find the derivative, just for fun, just because it's it is fun. The derivative of f is 4x, right? The 7 will go away, bring the 2 down in front. 2 times 2 is 4, 4x, and then we have times the original g, 5x minus 6, and then we have plus g prime. Well, g prime is just 5. And then f is 2x squared plus 7. All right, let's multiply in. That gives us a 20x squared minus 24x plus 10x squared plus 35. And then that gives us a 30x squared minus 24x plus 35. That looks like y prime. Now, in contrast to that, let's multiply and then take the derivative. 10x cubed minus 12x squared plus 35x minus 42. Okay, now I take the derivative. 30x squared minus 24x plus 35. Same answer. Either way, totally fine with you doing it either way. 6 of one, half dozen of the other. Questions about that? Good? Yeah. Thanks, Camille. It's always good when somebody responds back. Did anybody need to see 4 anymore? No? Okay, here's 5. Suppose that u and v are differentiable functions of x at x equals 5, and that a of 2 is 3, b of 2 is 5, a prime of 2 is negative 2, and b prime of 2 is 1. Alrighty, so why do I say at 5 though? I think I meant to say at 2. That's weird. Because it should be differentiable to 2 if I'm trying to evaluate it at 2. All right, so first thing here, 5a. Okay, we want to find d over dx of 2ab minus 3b when x equals 2. Okay, honestly, here, I've just got to find the derivative of all of these pieces. So this is 2, and then the product rule, a prime b plus b prime a minus 3b prime. Right? Or in other words, 2a prime b plus 2b prime a minus 3b prime. And then we just plug that in. Okay, so a prime of 2. A prime of 2 is negative 2. B of 2 is 5. B prime is 1. A is 3. And I'm just getting these from all of the stuff up above here. Minus 3 times B prime. 1. So that looks like it should be negative 20, 6 minus 3. So negative 17, I believe. Same thing for 5b. I want to find d over dx. Oh, that's simple. D over dx of a over b, which is essentially just a prime b minus b prime a all over b squared, right? Okay, well, a prime, again, was negative 2. B is 5. B prime is 1. A is 3. And B is 5. All right, that gets us a negative 10 minus 3 over 25. Negative 13/25. Questions about problem number 5? You good? I'll leave it up there for a second. And you know me, I'm pretty predictable. If it's on the review, is it going to be on the test?
If it's not on the review, is it going to be?
It's not going to be on the test.
That's it.
What about the exam?
Well, I'll give you an example.
That's what I'm talking about.
Yeah, just so you guys know where we're headed. Test Wednesday, Thursday of this week, 2-part test. Remember, it's not like a one-day calculator, one-day no calculator. It's just split into 2, just for time's sake. And you could probably take your test review and split that in half in terms of numbers, and that's where it's going to break day to day. So that's Wednesday, Thursday of this week. Friday is the, I'm going to give you the exam review. That's your work day. And then we're just going to go over it on Monday and Tuesday. And then I'll open it up I'm going to reserve Wednesday for any questions. Or if you need other time to study for anything else, I can open it up for that too. So I'm going to mainly be reviewing those questions on Monday and Tuesday. But if we need time next Wednesday, I can do that as well, if there's anything lingering. All right. Find the first and second derivative. Find the first and second derivative. All right, e to the x, x to the 6th. Okay, so product rule, right? Product rule. So that means f prime. Okay, e to the x, derivative e to the x is e to the x times g. Who's knocking on my door? Is that
Well,
not really? Yeah, that's fine.
just play the Home Alone thing.
Do you want to just set up right here? I'll come up here. Oh, please. Discuss amongst yourselves. I'll give you a topic. Rhode Island, either Rhode North Island.
I would have said no.
I don't know, can you?
That's fine.
So funny.
All right, e to the x, x to the 6th. That's f prime g plus g prime. Okay, 6x to the 5th. G prime f. So that's our first derivative. I'd like to reduce it a little bit, though. I remember this problem. E to the x quantity, x to the 6th plus 6x to the 5th. Because if we don't do that, we're going to have to do double the product rule in the next step. So that's f prime. And let's find, or sorry, y prime. And let's find y double prime. Okay, so that's another product rule. F prime, again, is e to the x. G is x to the 6th plus 6x to the 5th plus g prime f. F prime g plus g prime f. So g prime, 6x to the 5th plus 30x to the 4th times the original e to the x. And again, what I can do here is factor out the e to the x. So y double prime is e to the x, and then we can reduce by adding these things together. It's x to the 5th, or sorry, x to the 6th, excuse me, plus 12x to the 5th plus 30x to the 4th. Questions about that one? Doing all right so far? Hopefully.
You ever got a magician?
A magician?
Yeah.
They're having a magician come in?
Yeah.
Might have to.
Can we take a field trip tomorrow?
During this class? We'll see. We got to review for the test.
You gotta, yeah. I
Dude,
rather
magician.
You gotta-
If we review
You have a math magician
Oh.
as a teacher.
Wow.
I can make calculus happen out of thin air.
That's why they call them mathematicians.
Nothing up my sleeves.
It's all on paper.
Oh, Alec.
Keep them
I
out.
forgot it's live.
Leave them out.
Sorry, I forgot.
Leave them out in the cold.
We waited for it. We waited for you. All right, let's do number 7. Now that Mr. Harbaugh is back. A particle moves along a line so that the position at any time is given by the function s of t is equal to t to the 3rd minus 6t squared plus 13t plus 4. So s is position, measured in meters. T is measured in seconds. Find the velocity and acceleration as functions of t. What am I really asking you to do when I say find the velocity and acceleration? Yeah, find the first and second derivatives. Find the single derivative and then the double derivatives. All right, so let's do that first off. So v of t is the derivative of s prime of t. Ooh. And then we have 3t squared minus 12t plus 13. Okay, that's the derivative there. And now we can find s double prime, because s double prime is a prime, or it's not a prime, excuse me, just a. Acceleration, which is technically v prime, which is also s double prime. Right? Okay, now let's actually do it. Enough notation there. 6t minus 12. Okay, so find the acceleration after 3 seconds. That's a of 3. So 6 times 3 minus 12. So a of 3 is 18 minus 12, or 6 meters per second squared. Well, then it asks, at what times will the velocity be 4? Well, guys, remember this problem. I remember this from that quiz. 3t squared minus 12t plus 13. We got to know when that is equivalent to 4. It's quadratic. Subtract over the 4. 3t squared minus 12t plus 9. Let's factor out a 3. Let's divide out a 3. T squared minus 4t plus 3. Again, all I did was just divide by 3 here and here. And factor. Factors of positive 3 that add to get the negative 4 are minus 1 and minus 3. T is equal to 1. T is equal to 3. So 1 second and 3 seconds. The velocity is equal to 4. I think that is one of the coolest things about calculus, is that you could model the path of anything, and just by finding the derivatives, if you create the equation of the path, Just by taking the derivatives, you can calculate the velocity and the acceleration at any given moment. I just think that is so fascinating. That is just like, it can't get any better than that. All right, any questions about that? Find the equation of the tangent line, and normal line. We know what the equation of a tangent line is, but we should. What is the equation of a normal line? Anybody remember?
Opposite reciprocal slope.
Yeah, it's the perpendicular line. It's the opposite reciprocal slope line to that point. So if I've got y is equal to 2 sine x, in general terms, that's a vertical stretch of sine. So it's just kind of like an elongated sine. So at the point pi over 2, point pi over 2. So what's happening? Where is that? Is that 90? What's the sine value at 90? The y value. 1, right? That I'm talking about right there. Ooh, that's going to be interesting. See, next chapter, in chapter 4, we actually figure out like when these are happening and what does that mean about the derivative and stuff. But we actually are going to, I drew this diagram.
Does that help?
In this particular problem, yes, but that may not always happen. Let's keep going. Let's revert back to what we know. Y is equal to 2 sine x, right? If I want to find the equation of the tangent line, you find the derivative, and then you plug in that value, because that's going to be your slope. So y prime is equal to 2 sine x. Y was equal to 2 sine x, so y prime is equal to 2 times cosine x, right? Because the derivative of sine is cosine. 2 cosine x. So that's what the slope is going to be equal to, right? So the slope is really 2 cosine pi over 2. Okay, well, what's cosine pi over 2? And again, this is all full calculator. So if you really wanted to, if you don't trust yourself with the unit circle skills, you can plug it in. Cosine of pi over 2 is 0, which makes sense. What's the slope of this tangent line right there? 0. Interesting. So that means my slope is 0. Now, I have to create the equation of the tangent line. So it's y minus, do I know my y value yet? This gave me my x value, but I have to figure out what my y value actually was. Well, let's go back in here. Y is equal to 2 sine pi over 2. Again, if we didn't trust our unit circle skills, we could just say sine of pi over 2. But we all know that that's just 1 anyway, right? So 2 times 1 is 2. So that's the y value at this coordinate, right? Because it was a vertical stretch by a factor of 2. So y minus 2 is equal to m, 0, x minus pi over 2. But it doesn't matter what that x value is because that's going to go to 0 anyway. 0 times anything is 0. So this is y minus 2 equals 0. So the equation of the tangent line is y is equal to 2. Ooh, this gets even more interesting because if I want the equation of the normal line, what's the equation of a perpendicular line to a horizontal line? Well, that's a slope, right? Because it's a vertical line, right? You said because it was a vertical line. So that must mean, so this is tangent line. The normal line is going to be x equals, right? X equals what? Pi over 2. Go back to your original point. Ooh, that was a special case there. That was kind of fun. That's fancy. Didn't come out the way I thought it was going to when I originally looked at the problem. But again, what's interesting, and this is kind of foreshadowing again, what we get into chapter 4 is we start taking a deeper look into like, okay, when these derivatives hit 0, what's actually happening? Those are at those like peaks and valleys of the graph, and we start to get into more of the graphic analysis of derivatives. All right, I digress. Find the equation of the tangent line to the equation below at point 1, 0. All right, we got 1, 0, and we got that equation there. Oh, y's in there.
Yeah.
Let's go.
Yeah.
Let's go. What does that imply? I have to do what type of differentiation? Implicit differentiation. Here's what I mean by that. So I'm going to find this basically. Right? I want to find the derivative with respect to x. And the reason I put that notation in there is because I'm emphasizing the fact that we're finding d over dx, finding the derivative with respect to x for each of these terms. Well, that's just 0. Here is 6x. Here, I got to do some product rule, right? So plus 2 quantity, g prime, or f prime, excuse me. F prime is just x, right? So, I'm sorry, f is just x. So that means when I take the derivative of x, that's just 1, times the original second, plus g prime. Okay, what is the derivative of y? Y prime. Times the original g, or sorry, the original f, which in this case is x. And then the derivative of 5y is just 5y prime. Because it can't just be 5. Because when I take the derivative, I've got to be taking the derivative of y prime, right? It's like a chain rule type thing. All right, let's keep going here. 0 is equal to 6x plus 2y plus 2y prime x plus 5y prime. All right, I don't know. I always like y prime being on the left side. Let's get all my y primes over to the left side, shall we? So we are going to subtract the 2y prime x and subtract the 5y prime, leaving the 6x plus 2y on the right side. I moved over my y prime terms over to the left side. I leave just my x and my y on my right side. And now I've got to factor out the y prime, which is negative 2x minus 5. Oh, I bet that's low. Done that? Perfect. Thank you.
It's on Wednesday.
And then we divide over the negative 2x minus 5. So y prime is equal to 6x plus 2y over negative 2x minus 5. Now, if you did it another way, you might have gotten negative 6x minus 2y over 2x plus 5, which is essentially an equivalent statement. If you factor out a negative 1 from the bottom and put it up to the top, you would have gotten a negative 6x minus 2y. And then you would have had a positive 2x plus 5y on the bottom. Still the same answer, just written in a little bit different way. But that's not I'm not done. All of that work is just to tell me what the slope is going to be at 1, 0. So m is going to be, 1, 0. X value 1, y value 0. So 6 times 1 plus 2 times 0 over negative 2 times 1 minus 5. All right, so that gives me a 6 over negative 2 minus 5. So 6 over negative 7, negative 6/7. That's my slope. And I want to calculate it at that point, 1, 0. So y minus 0, oh, that's convenient. Y minus 0 is equal to negative 6/7 x minus 1. So y is equal to negative 6/7 x plus 6/7. That is just the equation of the tangent line. Didn't ask for the normal line, so let's not even worry about it. If I really wanted to, though, remember the equation of the normal line, I would do that exact same thing with 1, 0. Just flip that slope, positive 7/6, and then just run a 3-point slope again. All right, let's do one more. Let's do this last one on the front page. Number 10. Numero 10. For my Spanish speaking friends. Did I talk about that one day? Didn't I say like one day last week, like think about taking a math class, like if it's Spanish? I cannot imagine.
I don't understand it.
All right, let's find the derivative here. See, this is when we started getting into the chain rule, I believe. Because this is a chain rule. Sorry, that was a stupid statement. This inside piece, I've got it. Peel back the layer. What's the outermost layer? That to the 4th power, right? So this means that y prime is going to be equal to 4 2x cubed plus sine x to the 3rd, right? You leave the innermost function the same when you evaluate the derivative the first time. Peel back the layer. Now I can get into the inner piece. And now we find the derivative inside here. Now, luckily for us, the derivative, that's just two different terms. That's not like a product rule or anything inside there. So that would be a 6x squared, parentheses, plus derivative sign is cosine. And I'm going to say we can leave that there. We don't need to distribute or anything like that. You good, Marissa?
Yeah.
That's okay. I said we would do the front.
Wait, why are they multiplied together?
Because that's the chain rule.
Oh.
It's f prime
Right.
g of x times g prime x.
Forgot the chain.
Yeah. Remember, the chain rule always just says you multiply on the derivative of the inner parts. That's the chain rule.
That chain is so super order.
All right, we'll do the back tomorrow. Sound good?
Wednesday, Thursday, test. Friday, we get.
Friday exam.